Hey guys, Mr. B here, and this is my first video for the year for Math 2200, the new Pre-Calculus Advanced Grade 11 course. So basically what I'm going to do is I'm going to take you through the first section, Arithmetic Sequences, and here it goes. Alright guys, so before we start Arithmetic Sequences, let's just get out of the way what is a sequence. And we talked about this a lot in class, and maybe I'll just type it in here instead of writing it. And all a sequences is something that follows a rule or pattern. So an example of a sequence for numbers would be, say, we usually use like a little squirrely set of brackets like this, and it might be doubles. So 2, 4, 6, dot dot dot, and so it keeps going forever. So this one would double. There might be something that like every third number, so 3, 6, 9, or goes up by 3, that kind of thing. So all a sequence is some numbers that follow a pattern, so you can predict what's going to happen. There are two specific types of sequences in general. Infinite sequence, and they go on forever. So you'll often see the symbols dot 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 after an infinite sequence. So you'll see something like this. So like 1, 3, 5, dot dot dot. And that's called an ellipsis, and that means that this sequence goes on forever, never ends. So it's an infinite sequence. It doesn't have a set number of terms. Well, a finite sequence is exactly the opposite. It has a set number of terms. So set number of terms. So you won't see the ellipsis. So an example of that might be 1, 3, 5, 7, 9. So it has a set number of terms, and that's it. This one in particular has 5 terms. Within this, there are specific types of sequences. The first one we'll deal with is called an arithmetic sequence. So arithmetic sequence. And I've actually already given you a bunch of examples. And all an arithmetic sequence is it goes up by a constant amount. So increases by 2, goes down by 5. There's lots of different examples. Here's one. So you might have something like, let's make this one. So 5, 0, negative 5, negative 10, negative 15, so on. It goes on forever. So this one, as you can see, is going down by 5. And if we wanted to show that, all we would have to do is subtract successive terms. So 0 subtract 5 would be negative 5. Negative 5 subtract 0, negative 5. Negative 10 subtract negative 5, negative 5. And negative 15 subtract negative 10, negative 5 as well. So these guys right here, this right here, have a very specific name. And that's called the first level difference. And for an arithmetic sequence, something very, very important, for an arithmetic sequence, the first level difference, so the first level difference is constant. So what that means is when you subtract your terms, like we did, T2 subtract T1, and these are just terms of a sequence, so this would be T1, T2, T3, T4, and T5. When you subtract the terms of a sequence, T2 subtract T1, T3 subtract T2, successive terms as they say, you get the same number. So in our case we got negative 5. So that's kind of the key to arithmetic sequences. They have a constant first level difference. Now we can find a relation or a general term for this particular sequence by using a formula. I'll show you what that looks like now. So this is the formula for finding the general term of an arithmetic sequence. I know I'm going kind of fast here, guys, but I got a lot to get through here. So if you need to go back and rewind and listen to what I'm saying, you certainly can. Finding the general term of an arithmetic sequence. So this is what it looks like. T of n, which is our general term or the nth term, is equal to T1 plus n minus 1 in brackets times d, which is the first level difference. So we're going to put this guy, the easiest way to see how this works is just put it into action. So this is something that will be given to you on a test, I would say, by your teacher or by me if I am your teacher. Here we go. So let's find the general term. Sometimes you'll see it as relation or nth term I've written here. And your first step is always to find the first level difference. So let's do that. So 7 subtract 3 is 4. And once again, once you get good at this stuff, you won't have to write this out. You'll just be able to see. 11 subtract 7 is equal to 4. And then 15 subtract 11 is equal to 4. I'm going to sneeze, I got a feeling. So my first level difference, my D, and sometimes you see as D1, is equal to 4. My first level difference equals 4. So now let's use our formula. So we got T of n is equal to T1 plus n minus 1 times D. And sometimes you'll see D written out in front here, guys. Whatever you prefer, it doesn't really matter. This is the formula that I grew up with, so that's how I do it. But again, some of my students like to write D in front because you have to distribute through, and most people see distributing as going from the front to inside the brackets, but it's the same thing. It works both ways. So T of n now, my first term of my sequence is always this guy, so that's 3 plus n minus 1. A lot of people want to fill in n, but remember it's a general term. It has n in it. That's what we're going to be able to use it for, to determine what the value of the sequence is, or a term number is for any particular number. So I said that backwards, I think. What the value of the sequence is for a particular term number. So if n is equal to 10 billion, we can find what the value of the sequence would be instead of having to count up the entire thing. So now what we do here is we just distribute through, just like this. And then we have 3 plus 4n minus 4. So I multiply this, multiply that, and then I can just get rid of my like term. So 3 subtract 4, so that's 4n minus 1. So this is my general term. This is my general term right here, 4n minus 1. Alright, so that's really all there is to it. We can check to make sure it works. So let's try, well, we know when n is equal to 3, so the third term, n is equal to 3, should give us 11. And I wrote 1. So here we go. T3 is equal to 4 times 3 minus 1. So 12 minus 1, eureka, we get 11. So straightforward, fairly simple. Now there's, believe it or not, there's actually an even easier way to do this. And that's something I like to call the 0th term. Even though it doesn't make a lot of sense, because we know for the domain of a sequence, n has to be equal to 1 or greater than 1. So you can't really have n equals 0. That's why I sort of say the 0th term, because essentially that's what we're taking it as. We know that our sequence works forward this way by adding 4, but if we're going backwards this way, we should be subtracting 4 each time. So essentially, if there was another term here in front, the one that came before the 3, we just subtract 4 from 3 and we get negative 1. And what do you notice? That term is exactly this guy. So if you're familiar with y equals mx plus b, you kind of get the feeling that these two are very similar, where your difference d would be represented by your slope, and this plus or minus whatever the number is would be your y-intercept. So that's why if we work back to the 0th term, which essentially is your y-intercept, we can find a lot quicker what we have to add or subtract to make this guy work. So again, if I'm on a test and it's a long answer question, I'm breaking out this formula because my teacher wants to see workings, wants to see that I understand this formula. That's the outcome. But if I'm on a multiple choice question and I don't want to waste time with a lot of workings where there are possibilities for errors, I might just logically think about the connection between these two and find my 0th term by working back on my sequence. So let's try another one to make sure we got this under control. Alright, so here's another sequence. This one you can see the difference. Let's see. It's going down by 5, so minus 5. So my first step, found my difference. So T of n is equal to T1 plus n minus 1 times D. D is negative 5. My first term right here, 21. So I got 21 plus n minus then negative 5, and distribute this guy through. Just be really careful of your negatives now. So I got a negative 5 times n, that's minus 5n, and then negative 1 times negative 5, and that's a negative 1, so that's going to be plus 5. So that's going to be 21 plus 5 is 26 minus 5n. Now we like to rearrange it to look a little bit nicer, so that's negative 5n plus 26. I think I said 21 there a second, but it's 26. So here we go. That's my general term. And again, you kind of could get that what you add or subtract here right away, because you notice the negative 5, that's always going to be in front of my n, so that's what you got. This way it's going down by 5. If we work backwards, one more, so we went 5 that way, we'd get to 26, which is this guy. So we could have used that as well to just quickly get it, or even just do a check. And then we can check our answer to make sure it works. So this is T2. Let's try T2. 2 times negative 5 is negative 10. Negative 10 plus 26 is 16. Booyah, we got it right there. 16. Alrighty, so let's try a slightly harder application of this type of question. This is one that I gave you guys in a couple of mad minutes, but anyway, let's have a look at it and see how it works out. Alright, so the following is an arithmetic sequence. What is the value of x? So what I always tell my students is when you see a question like this, think about what you know about arithmetic sequences. So there's not a whole lot we do know. We know they have a common difference. They go up by a constant amount. Their general term looks like this. T of n is equal to T1 plus n minus 1 d. They have some characteristics similar to y equals mx plus b. And that's all we know. So when we're doing a question like this, if we wanted to prove it was an arithmetic sequence, all we would do is find the difference. So let's have a look and see if we can find the difference of these guys. So 8 subtract 5, let's do some brackets, plus x, looks like that. So let's just do a little math on this. So 8 subtract 5 is 3, and there's nothing over here. We have a negative x, so subtract x. Be really careful. A lot of people mess up in fact. You got to go through with this and change everything to the opposite sign. And then we'll do the exact same for this guy. So 1 plus 2x minus 8 is equal to, so 1 subtract 8 is negative 7, so 2x minus 7. Now, these are my common differences. So in an actual arithmetic sequence, we actually have numbers here which will be the same. But we don't, we have like expressions. So 3x right there, and then 3 minus x, and then 2x minus 7. So these are expressions. But since it's arithmetic sequence, we have a common first level difference. So these things should be equal to each other. So we can go like this. 3 minus x, and then 2x minus 7. So all things well and good, these equal each other. We can solve this guy. So let's solve it for x. So again, solving this thing is kind of something I assume you're pretty good at. I'll take my time here. So I'm going to add 7 to both sides. Actually, I'm going to change my mind on that one. I'm going to subtract 3 from both sides. Subtract 3, so I end up with negative x, this goes away, is equal to 2x minus 10. Then I'm going to subtract 2x from both sides. The reason I changed my mind is because I like the x's on the left-hand side. It's just the way I am. And then negative 3x, this goes away, minus 10, and then I'm going to divide both sides by negative 3. So x is equal to 10 over 3. So that value of x works to make this an arithmetic sequence. And if you're on a test, you could just check it, plug it into your actual values, and see what you would get. I'm not going to do that now, but you could always check. So there are other possible problems you can get with this, guys, but really, what you need to know is this guy and what a common difference is. Really important, fundamentals, especially for the next section. Hope this helped, guys. I'll see you in class.